Hey everyone, welcome to this Cloud Lunch and Learn Marathon. I'm going to talk about demystifying service principles and managed identities. One of the, I would say, key important aspects of using Azure as a cloud platform, where it means that we're going to work around managing your credentials in a bit more efficient way that you probably are using at present. Now, before jumping in the technical details of today's session, let me first of all thank our two sponsors, being Microsoft and Redgate. Why? Because without any sponsorship, even in a virtual online conference model like this one, it would even be possible. So thanks for that. Next to that, obviously, I would like to thank everybody else who is involved in organizing Cloud Lunch and Learn. First of all, I would say thanks to the organization for allowing me to present at the conference. And just for your information, I'm not just presenting one session, but I've been doing 3 sessions today. So feel free to check them out. One is covering Azure Container Services, starting from Docker all the way to briefly touching on the different container runtime options we offer in the platform. And I also have a session on Azure DevOps and talking a little bit about pipeline magic. So with that, I think the practicalities are almost done. Besides, I'm also thanking the collaboration we have here from a couple of other Azure-focused user groups, the C# Corner, .NET Mafia, Dublin Azure Meetup, and Cloud Family. If you want to stay in touch, feel free to reach out on Twitter. My tweet handle is PDTIT, and obviously try to make some buzz here using the Cloud Lunch Learn tweet handle or the hashtag CLL Marathon. So with that, let's jump in the real topic of today, and starting with a little recap of identity. Why? Because identity is really the core around Azure security, handling user authentication, which means whatever you're going to do in the platform from an admin perspective, developer perspective, and obviously later on a system perspective, you need to authenticate. So that's really what this session will be all about. Once you have a pretty good idea about Azure identity itself, I'm going to switch to the main topic of the session, highlighting service principles, managed identities, how they're similar, how they're slightly different, and most important, how you can use them. Showing them how you can use them will rely on any of my hopefully live demos that I can walk you through, because I'm still convinced that hearing about it, reading about it is all fine, but seeing it in action is probably even more cool. Now, before jumping in, let's think about some of the possible scenarios where you might wonder, why should we use Azure Identity? Why should we use service principles and managed identities? So for example, your Azure admins are running Azure deployments in their own name, which means they need permissions to do that, right? Or maybe your developers, they can touch on the Azure platform and touching whatever they want, and even whenever they want to. Or maybe you paid attention and you listened to one of my Azure DevOps sessions here during Cloud Lunch Learn, where now you go like, well, but maybe my DevOps team actually needs source control credentials, and we're going to store them in connection strings. We're going to store secrets like local admin passwords, maybe in source control, which, by the way, obviously is not at all a good way to do so. And that's going to be one of my examples later on. Maybe you want an Azure App Service to interact with Azure Key Vault. I'll talk a little bit about Key Vault later on. But in short, it allows you to store secrets instead of storing them hard-coded in your source code, in application source code, ARM templates, Terraform templates, whatnot. You could move them into Azure Key Vault. And then last, any other third-party scenario where you need some kind of integration with Azure will be a valid scenario for service principles or managed identities. And so many more, but hopefully that will become clear a little bit later on. Now, before diving into the technical topic of today, let's share a little bit about myself. So Peter de Tender, based out of Belgium, and currently for almost 2 years now, working as an Azure Technical Trainer within Microsoft. It's most probably one of the most easy job titles ever within Microsoft, where it means that I'm providing Azure Technical Training almost every single week to our global customers and partners, but out of a virtual EMEA region, where before the pandemic, everything was mainly happening on site at a customer or at Microsoft locations, and providing training to smaller groups like 20 on average, but it could expand to like 200 with training, hands-on labs, and anything in between. Before I joined Microsoft about 2 years ago, I was running my own company for about 10 years with a core focus on Microsoft technologies, help. Good, we're almost there. So last thing I want to talk about before switching to the technical topic of today's session is maybe sharing a little bit about myself. So Peter de Tender, based out of Belgium, and currently working for almost 2 years within Microsoft as an Azure Technical Trainer. It's probably one of the easiest job titles ever. It means that I'm providing Azure Technical Training every single week to our customers and partners from anywhere in the world, but out of the EMEA time zone. Currently, out of the pandemic, everything switched to virtual deliveries, and before we were typically providing those workshops on site. Before joining Microsoft, I was already pretty passionate as an Azure trainer, consultant, and solution architect out of my own company, out of which I helped global customers onboarding to the cloud or migrating from on-prem, maybe establishing hybrid scenarios. Was an Azure MVP for a bit more than 5 years. Before I was a Windows IT Pro MVP, because before I started using Azure about 2010, the end of 2010, early 2011, I was pretty active as a traditional Microsoft data center guy, I call myself, literally deploying Windows Server, Exchange Server primarily, and everything around it in on-prem data centers. And then in the little bit of free time that I had, where before the pandemic it was mainly in boring hotel rooms waiting at airports, or why not, while I was on a plane somewhere to Asia or US, writing technical books on Azure. And you can see here a couple of, I would say, the last published titles from the last couple of months, although all 4 of them took me about 3 years in total to write them. If you got any questions, feel free to reach out. I would say we already talked about Twitter, so feel free to shout out. Or later on, if you're watching this as a recorded session, don't hesitate reaching out. Email would be preferable, petender@microsoft.com, or using Twitter. And why not, maybe have a look at my blog, 007 FFF Learning, to keep up with some technical updates around Azure. So with that, let's jump into the technical topic of today's presentation, where I'm going to start with Azure Identity. Azure Identity is, or Azure AD at least, is our trusted identity object store in the cloud. You might be familiar with Active Directory. It's been the go-to identity solution for on-prem scenarios, where you're going to build user accounts, group accounts, and you could also store workstation and Windows Server information in there. Once the identity is known, is being created in Active Directory, it becomes a trusted object, which allows you to log on with an Active Directory user account to a trusted Windows client in the domain, and from there connecting to applications running on top of a Windows Server environment like a web server, SQL database server, or any other application scenario. Or you could also become a member of a trusted Active Directory group, like a finance, IT group, or anything else you were looking for. And if you were a member of that group, you could get access to file shares and anything else that could be important. So the identity, I would say, is really the starting point. Now, out of the identity, we're going to move it into a cloud-based model, where you have Azure AD Connect. It's a cloud-based synchronization tool in meantime, but you could still deploy it on-prem as well. And what it allows you to do is moving your existing users, groups, and device objects into Azure Active Directory, literally synchronizing all of them, or selective, not just synchronizing all user accounts. But in the end, we end up with Azure Active Directory, where now Azure Active Directory becomes our identity trusted environment. Each and every user, each and every group, each and every device, where in meantime Azure AD also supports mobile devices, will be seen as a trusted object. Where we can still do the same thing. We're gonna authenticate to some cloud application using Azure AD, which by the way is relying on OAuth OpenID Connect. So if you're authenticating to Office 365 in the backend, you're going to use an Azure AD account. If you log on to the Azure portal, you're going to use an Azure AD account. Now, instead of just being an Azure AD user and interacting with other applications like Microsoft 365, like Azure, mainly zooming in on Azure for now because it needs to move into service principals and managed identities. We'll get there, no worries. But what it allows us to do is defining a user account within Azure AD, our Azure AD tenant, and from there we're going to, for example, define role-based access control. Now, what is role-based access control? It's where you're going to define admin level permissions. I'll walk you through a demo in a minute, where you can enable user permissions. Like if Peter logs on to the Azure subscription, Peter can deploy virtual machines, can deploy web apps, can deploy databases, but only in the Peter subscription, not in any other colleague subscription, for example. Next to that, you can define permissions on individual resource level. I would say it's not really recommended because it's a little bit of admin overhead. Probably on resource group level, on subscription level, maybe tenant level, but that would be a little bit risky in like an enterprise environment because you might end up with having too many or too much credentials, like too high privilege. And if you have a single tenant with multiple subscriptions, you could also organize them based on management groups. Now, role-based access, already talked about it a little bit, gives you about 70 predefined roles, but if you want, you could also customize it and coming up with maybe, I never really counted them, but maybe a combination of more than 10,000 different settings, where instead of being a full Azure admin, you could be all the way down to a super granular level of admin permissions. So with that, let me switch to my first demo, where I'm already authenticated. Nothing too fancy about it, just the fact that I'm using Azure AD, which, by the way, you can extend with multi-factor authentication. You can extend with conditional access, allowing you to define conditions under which you can authenticate, where it might be possible to block my access to the Azure portal, to Office 365 or any other Azure AD integrated application, where I can log on from a trusted device in the same Azure AD, but if my device, like my personal mobile app, is not recognized, not registered in Azure AD, I can, for example, not connect to the Azure portal. I cannot connect to Exchange Online or any other scenario you could come up with. So my starting point is Azure AD, and from here we have the user list. I'm only filtering for my user because I'm using the Microsoft directory and not really relevant, I would say, for what I need in my demos. So from here, I can read out some information from my user account, and I can see that I do have a set of assigned roles. So from here, it's going to show me like, nothing's really active. Now what's going on? It's because I'm opening it up from within Azure AD. I'll switch back to another part in the Azure portal and showing you what it looks like from a role-based access perspective. This is also a limitation in specifically our Microsoft environment because I don't have all permissions to really manage my Azure AD environment. So don't worry too much about it. So let's go to our resource groups, where within the resource groups, we're going to define who can do what. That's really the scenario. And obviously within a resource group, we're going to define what resources we have. This is a pretty basic resource group, and within I have my storage account or anything else, right? Doesn't really matter. Now imagine that Peter is an Azure admin and I used to be a storage appliance admin in my on-prem environment, which means when I'm authenticating to Azure, I only need access to manage storage accounts, and maybe even more granular, I only need permissions in this specific resource group to manage storage accounts. So what we can do is moving to access control here, role-based access or identity and access management, and we can define specific permissions. Now I showed you in the previous Azure AD blade that I don't have any permissions, but actually I do have quite a lot of them, where you're going to see that nothing's really showing up besides the fact that I'm a service admin. Used to be the owner permission in the subscription. I could go to subscription level. Let me open up second blade Well, now if I look at subscription and checking back my access control, it's still going to show me the same thing. So a little bit confusing, right? Because I'm pretty sure I have the correct permissions on my environment and I can do whatever I want in my subscription. Now, if we want to lock it down, and I'm using my own account, this obviously could be any other Azure AD account in your environment, or even a group of accounts where we're going to add a new role assignment. Now, the role assignment is again based on role-based access, where we have this pretty interesting list of permissions for a lot of different specific Azure resources. And I could define that I can do anything. Now, one of the, I would say, the most popular levels is owner, contributor, and reader. Now, what it means is that you are an owner. It means you can create resources, you can modify them, and you can also change permissions, like really modifying access control. If you're the contributor, it means that you can manage your resources, your resource group, your management group subscriptions, remember, all the way up to the tenant level, but you cannot change permissions. So my recommendation would be to identify your traditional admins that used to be system admins on-prem, at least providing them contributor permissions if that's not already too elevated, and only a handful of admins would be the full owner in your subscription. Now, for this specific example, imagine that my user account Peter only needs read permissions to the blob storage. I would define the storage blob data reader permission, which means I cannot even manage the Azure storage account anymore. But out of my Azure AD, if I would install Azure Storage Explorer and connecting to the blob storage account, I could still read the data. So that's like what the permissions are referring at. If that list of 70 something is not good enough for you, or it's maybe a bit too open or maybe a little bit too narrow, you could also create custom roles. This used to be PowerShell based only, but in meantime it's also nicely integrated in the portal, although most probably in an enterprise environment, you're probably still going to rely on the PowerShell integration or maybe infrastructure as code. Now, just to show you how easy it can be, now you could start configuring this from the portal. I think it's one of the nicest demos I can do here, but you could also automate this using PowerShell or even infrastructure as code. Now, just to give you some idea, you can filter on pretty much any Azure service. So since my example was based on a storage account, let's search for storage account, and it's going to filter out of all the services that we have, which of the services provide admin permissions towards storage accounts. Where next I could select Microsoft Storage. Here we go. And within the storage account, I could filter on pretty much anything from a super admin level permission, like you got all the permissions, to you can only read the blobs or you cannot even do anything with blobs or anything else. That would be the idea. Now, the other example is Cloud Shell. Why? Because I'm logged on to my Azure environment. I have my correct role-based access. And from here, I can move them, I can port them into Cloud Shell. Now, what is Cloud Shell for the ones who don't know? It's a cloud-based, portal-based PowerShell environment that's already authenticating you to Azure. And you could easily switch from PowerShell to a bash script, for example. Or if you would like to run this from your local machine, where you have ARM template deployments or some other scenario where you want to interact with the Azure backend, it means that you always need to authenticate, which works perfectly fine. But I hope you have some idea that it's fine from an interactive user perspective. I'm Peter, I'm logging on to my Azure subscriptions, I'm going to deploy resources or anything else. But what if this is like another environment, like maybe third-party scenarios? And that's one of the main features, I would say, to start discussing service principles. Why? Because a service principle is an application. We're not talking about a user environment anymore, or like an interactive user logon, but it's technically any application whose tokens can be used to authenticate. So it's still identity based, and yes, it's coming from Azure Active Directory to authenticate an application, and on top of that, granting access to Azure resources. So think of a third-party application. You might have a DevOps pipeline scenario. I'll walk you through a demo with Azure DevOps later on. You might have any other application that interacts with the Azure backend, with the Azure resource providers, where you don't want to rely on individual user admin permissions anymore. And yes, you need to use Azure Active Directory as the, obviously, dependency there. So a little bit more in depth. The service principal is everything I talked about up till now in the last 20 minutes, starting from Azure Active Directory with a user account, a group object, and using it for authentication and authorization. But super important, it's not linked to an individual user, it's not linked to a group, because then you would still use Azure AD users and groups. So it's going to help you in replacing what I call fake service accounts. Like in an on-prem data center scenario, if you deployed Exchange Server, if you deployed SQL Server or any other workload, maybe like a third-party backup tool, you would typically create a service account, where next you would give the service account specific admin permissions, like you becoming the backup service account, meaning when the backup agent is running, it's going to impersonate you being the backup admin. And typically the backup user had quite some privileges because it could touch on all the different systems in our data center. So to avoid something similar with any other third-party application, that's where we're going to turn in our admin user into a service principal concept. Everything I showed you around role-based access can be used for a service principal Azure Identity object. If you have a third-party application that you're going to use to deploy Azure, let's say Terraform. I got an example on that later on. Where you're going to use Terraform, you could run Terraform deployments out of the Peter admin account. But maybe you don't want that anymore. Or maybe you're using, again, some DevOps scenario where you're not going to run a pipeline in an admin account's name, but you're going to create a service connection. But more on that in a couple of upcoming demos. So basically any scenario where you want to interact with Azure that relies on an authentication token, but not using an individual user admin account credentials scenario anymore, that's where service principals are coming in. So hopefully it's, I would say, understandable enough from here what a service principal can do. And if not, I'm going to walk you through some of the core scenarios. So let me close this out for a second and go back to my base Azure environment. So imagine I'm running a pipeline deployment. I'm using Azure DevOps. For the ones who are interested in Azure DevOps, I have another session here at Cloud Lunch Learn where I'm trying to cover as much as possible in 60 minutes about using Azure DevOps for some cloud magic. So what we can do is going back to our project, where I'm just going to select any of them, not that important. And I'm running a release pipeline. I'm using Classic, but this would also be the same concept using YAML, where we're going to deploy something against the Azure platform. So what I'm doing here is grabbing some source code, moved it into a build scenario, and the outcome of that is an artifact. Think of it as a web deploy package, for example. From there, I'm going to move this into my Azure environment, where I'm creating two different stages, a dev stage and a production stage. In the back of each and every stage, I'm identifying like what is my target environment. In this case, I'm publishing to Azure App Service, and my web app is known as the DevPub AZ400. Why? Because I delivered the AZ400 DevOps training only yesterday, and I want to integrate this existing demo because I don't have that much time to focus on service principles. And it's obviously not about Azure DevOps. Now, if I want to run this pipeline, again, first of all, I'm authenticated as Peter. That's what you can see up here. I'm authenticated to Azure DevOps as Peter, but I don't want to run this pipeline in my Peter admin account. Why not? Because we might have different admins, different Azure DevOps, overall DevOps engineers connecting to our pipelines and running them, where it wouldn't be a best practice anymore to run this in each and every individual account scope. So what we're going to do is defining an integration with our Azure subscription. If you're targeting other platforms than Azure, you need to look into the identity and authentication scenarios they're offering. If you're targeting like Docker Hub, you need to create a Docker ID. If you're targeting AWS, you're going to create an AWS ID. So that's, I would say overall, we're still using an identity system. In Azure, it's called Azure AD. And from there, we're going to move it into an identity scenario, but we're not going to link it to an individual user account anymore. So let's move on and show you how you can create this integration. Now in Azure DevOps, we talk about service connections. If you're using other tools like Terraform, I'll show you. If you talk about any other, the titling might be slightly different because it's obviously up to each and every tool, but the concept will be the exact same thing. So we have a service connection, and I already have one just to speed up the demo a little bit, but I can show you how you can create a new one. So don't worry too much about all of the other third-party tools. I'm going to target my Azure environment. Now what we need to do here is relying on service principal, automatic, manual, and later on, as you already know from the title, I'm going to clarify managed identity as well. So service principal automatic is an interesting one because it's going to do everything automatically for me, which means I don't need to create a service principal in Azure AD, copying all the settings and moving them here, but it also requires elevated permissions, where typically your DevOps engineers most probably don't have them. So what we need is a service principal manual option. What is the manual option? It's where typically my identity team or maybe my security officer is creating a service principal object. And from there, once it's created, he or she is going to share that information with me. So let me go back to my Azure environment and creating a new service principal. I'll first show you what it looks like from the Azure AD portal. Now, if you look in the Azure AD portal, you're not going to find any information that's called service principal, which, by the way, if you're interested in not exposing all the details about your Azure environment, there's an interesting extension for Chrome, and it works in Edge as well, to mask like secretly alike information. So feel free to maybe have a look at it. It's called AZ mask. Now, that's maybe, I would say, one of the confusing parts, and that's partly why I started talking about this at conferences, where before we talked about app registrations, or maybe you heard about managed service identity, and it's all about the same, but it's not exactly the same. So let me clarify that a little bit. So technically, it is still an app registration. So a service principal is somehow the same as an app registration, with the core difference that a service principal is an app registration, so it still gets stored in Azure AD, but it also receives admin permissions based on the scoping you defined. So I could create a new app registration from here. I could give it a name, defining what is the Azure AD tenant you're going to use. And once it is created, you would define specific permissions. So for example, my AKS cluster, it's a Kubernetes on Azure cluster, also requires you to define a service principal or a managed identity. You can choose. So what it means is that my object in Azure AD called AKS cluster receives the correct permissions, role-based access, to interact with the platform. Why is that? Because Kubernetes, when you install Kubernetes as a service on top of the Azure platform, it's going to build virtual machines for you, like the Kubernetes hosts. It needs interaction with Azure networking to make sure that the pods can connect to the public internet or the other way around. It needs interaction with Azure Load Balancer and a lot of other capabilities and permissions, where now instead of creating so many different admin accounts to do that, we're going to define, hey, AKS cluster, Azure resource object, we're going to give you necessary permissions to interact with the platform. And that's what we call a service principal. Another option is creating this from command line option, where the command would be azad. Let's give it a second. So first of all, I'm pre-authenticated as the admin Peter, because that's how I authenticated to my Azure environment. And from here, let's clean it up a little bit. Oh, I would like to switch to Bash. I don't know about any one of you in the audience, but somehow I would say more a fan of Bash than PowerShell. Although PowerShell has been around for a couple of years already, the assumption could be that everybody knows PowerShell in the meantime. But for some reason, I'm still suffering a little bit more with PowerShell than Bash. Maybe because the syntax looks and feels a little bit easier, I don't know. So what we're gonna do here is running a command called az to interact with Azure, ad, no secrets, interacting with Azure Active Directory, sp for service principal, where next to identify that we're gonna use this for service principal interacting with role-based access, we're gonna use create for RBAC, and to make it a little bit familiar, like what kind of user account or identity object are we creating, we could add a name. So this would be the Cloud Lunch service principal, something like this. From here, when I push my return and confirming the command, it's gonna create that user account. And again, I'm talking about the user account, but technically it's not linked to the user, so it's gonna create a service principal, but just mapping that it's almost identical to any other identity object I talked about before. And something is not working. Makes sense. I forgot to add the setting name. Obviously, Cloud Lunch is not a parameter. It would be a name setting. There we go. So now it's creating a Cloud Lunch service principal, and it's exposing some information. Now, why is this important? Because that's the information we need. So imagine that my Cloud Lunch Learn would be my service principal that I'm going to use in Azure DevOps. And if everything works out fine, it should show up here as well. There we go, Cloud Lunch service principal. And it's going to show me the app ID, some password and whatnot. That's for obvious reasons, I'm not exposing the exact details. I have a funny story on that where I was doing the exact same demo during a live training, so it was not a recorded session, but still, where somebody was literally screen capturing it and next to that storing them in GitHub, where interesting enough GitHub has a repository source control security scanning, and it recognized it as a token. Now, by the time this session is getting streamed, the token is already gone, so it doesn't make any sense to go out and try because that account won't even live for the next 10 minutes after my session. So nothing to worry about. But from here, what I would need to do is going back to my Azure DevOps environment, where now my security officer would go like, hey, Peter, I created a Cloud Lunch Learn service principal for you. And by the way, just to speed up the demo a little bit, I could move it into role-based access, creating a resource group, defining specific permissions. Like out of this service principal, you can only deploy resources in this resource group, but nowhere else in the subscription. But what I need to do here is literally copy pasting subscription ID, subscription name, principal ID, and principal key. 4 lines of information as the output from that azad create for RBAC bash script, and copy pasting that information. From here, I could verify, save, and successfully running my pipelines, where the outcome would be what I showed you before. If I'm going to run this pipeline, it's now running, obviously not in the Lunch Learn, but using my existing service connection called Microsoft ATT subscription or anything else. I mean, it's just a name that you create. And that's in short what, Service Principal is doing. Now you go like, well, that's all fine, but I'm not really using Azure DevOps, so interesting demo, but it doesn't really reflect what I'm looking for. So maybe you're using another tool. I'm using any third-party tool. This is something I discovered a couple of months back. You might be familiar with Puppet, like the configuration as code tool for cloud on-prem hybrid scenarios. And since a couple of months, they provided a cloud-hosted service called Relay. And what Relay allows you to do is interacting with cloud platforms or public cloud, on-prem cloud, but instead of building like a full management tooling around it, like before deploying Puppet servers, you could now manage this from a hosted environment. So it's available as a free test, so feel free to play along, I would say. And one of the scenarios I have in mind is from here interacting with Azure. Could be AWS, could be Google Cloud, but obviously since I'm talking about Azure service principles and managed identities, I would go into that route. If I want to interact with my Azure environment, it means I need to establish that connection, similar to what I showed you before. From here, add connection, interact with Azure, and the system is going to ask me the exact same questions. Provide me subscription ID, service principal, tenant, and the password or the secret from that service principal. Exact same thing. Or maybe you go like, well, that's all fine, but I'm not really using this, but I'm using Terraform. So the way you would deploy in Terraform would be the exact same thing. You could create your Terraform file, and inside that file, you're not going to run your Terraform deployment in your Peter admin scope, but you would run it in that service principal scope. So what you would need to do here is adding a little syntax, provider Azure RM, that's like I'm going to target the Azure platform, and I'm providing the specific service principal information. These 4 lines is literally what's coming from that output of that AZAD create for RBAC. Even better, you go like, well, Peter, but why are you storing your credentials in each and every Terraform deployment file? Now, obviously, again, it's not really about the tooling, but what you can do is instead of storing it hard-coded in your Terraform scripts is, let me pull up another example. If it wants to, come on. Apparently not. Let's try that again. Nothing crucial, I would say, but every now and then that question comes up, so I rather tackle it before somebody's reaching out on Twitter. But what you can do is creating a Terraform variable file. I'll try to make it a little bit bigger. So instead of storing my credentials hard-coded in each and every Terraform deploy file, you could also store them in the Terraform variable file, but the technology, the concept, the scenario would be the exact same. You have your credentials from the service principal and you're going to store them somewhere. And I think that's about it on service principles, which hopefully awoke you a little bit and wondering like, why is this or what's going on? So you have the security officer or some Azure AD admin. This person is creating the service principal and sharing that information with Peter or any other admin for this matter. So first of all, somebody needs to create that service principal. Next to that, as I tried to show you from Azure DevOps, the Puppet tool, any other third-party tool, doesn't matter, the Terraform example, the client ID and secret, like the core credentials, are literally exposed and known to the person who's creating the service principal. Next to that, because we need to share it somehow, it means that the consumer also has access to that information. And if you create a service principal, the default validity of the account credentials is 1 or 2 years. And that's why we have managed identities. So what are managed identities? They're 100% service principals, but linked to Azure resources, first of all. So instead of integrating third-party tools, this is only valid for Azure resources, up to a certain extent. I'll talk about it. It means that, for example, you have an Azure virtual machine and you need interaction with an Azure storage account, where maybe before you were using service principals to build up that integration. Where now, instead of using a service principal or maybe some admin process where you log on to the VM as the Peter admin account in Azure and establishing a PowerShell script to mount a storage account or anything else, we're not going to do that anymore. We're going to rely on system communication, Azure Resource 1, virtual machine connecting to Azure Resource 2, in this example, a storage account. Maybe you heard about it before, where we talked about MSIs or Managed Services Identities. Remember, we have app registration, service principal, and now we have managed identities. All doing the same thing, but slightly different and using different terminology. The biggest benefit, however, what makes managed identities like really cool, is they're automatically created for you. You go into the Azure portal, you need some admin level permissions to turn a resource into a managed identity. But apart from that, we're not exposing anything. You don't know the credentials, you don't know the password, and maybe even more important, it's linked to an Azure resource. So now we can establish an integration from Azure VM 1 to Azure Storage Account 2, and we just establish it based on what Azure AD integration offers me and based on what managed identities are offering me. Now, when you enable managed identity as a setting on top of an Azure resource, you're going to see that there are two different options. The first option is system assigned, which means that it's going to link the service principal identity concept to a single Azure resource. If you have 50 VMs, you're going to create 50 service principals, you're going to create 50 virtual machines, which means you're going to create 50 managed identity system assigned scenarios. You could link them to a logic app, a storage account, and anything else or almost anything else that you deploy on top of Azure. Not all services today support managed identities, by the way. Next, you have a user assigned model, where user assigned means that first of all, you're going to create a managed identity, but we're still not exposing the credential details to the person who's creating the object. And next to that, you can link your user assigned managed identity to multiple Azure resources. The system assigned benefit is that it's a one-on-one relationship. Easy said, if you delete the virtual machine, managed identity will also get deleted. In case of user assigned, you create a managed identity first, and you're going to link it to multiple resources. If you're wondering about some more details between system assigned, user assigned, and what way to go for, I need a little bit more time that unfortunately I don't really have, but I would say my best practice, and partly the Microsoft best practice, but depending on all characteristics, all possible scenarios, as long as you have that one-on-one relationship as a security model, you would go for system assigned. If you are okay with creating one user managed identity, and I know the title user is a little bit wrong because it has nothing to do with user accounts whatsoever, with admin accounts whatsoever, it means that you're going to create this single managed identity object and interconnecting it, linking it to multiple Azure resources. So a couple of scenarios where I'm technically using it. Imagine you have multiple Azure resources all working together to build up your one single workload. You have a virtual machine, a web app, file server on a VM, a web app, SQL database, a Cosmos database, and anything else where the application can only work when all resources are available. In this case, I would recommend one single managed identity to connect to any of those 5 resources. That would be one option. Or maybe you have an idea where you're going to turn an Azure resource, like a virtual machine, into a managed identity, and you're going to provide a read access to Key Vault, reading out secret information out of Key Vault, where maybe you could turn it into a user-assigned managed identity, where now you're going to define this user-assigned managed identity can be linked to whatever Azure resource, but the only permission it gets is read information from Key Vault. So a couple of different scenarios that could help you a little bit. So in short, you're going to start from the source. Think back about some of my scenarios before, where you are a developer, or maybe sysadmin, or maybe a DevOps engineer, and you want to build an application that's running on top of Azure, where the source can be any Azure resource, or almost any Azure resource. I provided the link here in that super light blue, but that's where our official documentation explains all the different Azure resources that are supported. From any of those source Azure resources connecting to any Azure target environment, Key Vault is a popular one, storage accounts is a popular one, Azure SQL, Cosmos DB, without having to manage any credential whatsoever. It's one system Azure resource connecting to another system Azure resource. And it's magically happening if you want. So enough about talking. I got about 10-15 minutes left, I guess, so pretty good on time. And let me walk through another demo scenario. Now, I talked about Key Vault as one of the prime services. You might know Key Vault already, maybe not, and that's where you're gonna pick something up. So imagine my workload that I have in mind for my demo is a collection of Azure storage, functions, logic apps, and anything else. So I have everything in my resource group where I'm using serverless, because all the technology I talked about is known as serverless on top of Azure. So I do have a cognitive service. I'm using an app service plan. I'm using API connection out of logic apps. I got a Cosmos database. I got a function app and whatnot. Now, out of my function, just an example, I need interaction with a storage account. So what I do, I create my function, and from there, I'm gonna, for example, export license plates. This is like a full boot scenario. Imagine that you have customers pre-registering with a mobile app, with a credit card. They arrive in front of the gate, and we're gonna install a little camera that's gonna recognize the license plate, and from there capturing a JPEG file, storing it in Azure Blob Storage, and that would put everything in motion. If the license plate is recognized because I pre-registered from the mobile app, we're gonna open the gate, and that would be the scenario. So we have a little app, and what we have inside that app is an interaction with other parts of the platform, where one option is storing those in configuration settings. I would recommend to use it instead of storing it hard-coded in the web config files or app settings files, or maybe even better, instead of storing them here individually for each and every function or web app, you could also move them into the app configuration service, which would offer you the same but in a more centralized management option. Now, what I'm doing here is, instead of hard-coding my actual connection strings for Azure Storage, for SQL Azure, for Cosmos DB, instead of storing them hard-coded in my app settings here, I would move them into Key Vault. And that would be a security best practice for obvious reasons. So let me open a new tab to just allow me to easily switch from one window to the other, where I'm going to open my Key Vault. I create a specific Key Vault for my specific application workload, where I'm defining a set of keys and some secrets. Behind the secrets is my actual blob storage. So I could go to blob storage if I do have the admin permissions. I would copy it out, and the same for API keys and whatnot. Now, back to my functions, where now I need to tell my function, I need to configure my function to have specific correct permissions to communicate with Key Vault. Permissions in Key Vault for now are managed using access policies, where you can use specific Key Vault permissions or role-based access, what I talked about before, right? So what I did is going into my function, going into identity, and enabling my individual function app as a system assigned managed identity. You could do this using command line, but I'd like to show you what it looks like from the portal perspective. So I created my function app and defined it as a managed identity, system assigned. We're now within Key Vault. I can define access policy. You can read out like get and list for the secrets. And this time we're going to link it to a principal. Again, it's called managed identity, but terminology is a little bit overlapping every now and then. Where now I could search for my PDT Tholboot function. And that's my managed identity object. So a little recap up till now. I have my function. I need some secret information to make sure that my function is working and be able to connect to storage account, to a database, literally using connection strings. Where the connection string characteristic is that it uses a database name, username, password to allow me to connect to the database, and that's secret piece of information. That now we're going to move into Key Vault. That's step 1. Step 2, we're going to turn our function, our Azure resource, into a managed identity, one-on-one, system assigned. This function reflects one single managed identity, and next to that we define permissions. And then last, but that's just for the demo scenario, I need to translate my configuration settings into something understandable, that it's now not having the actual secret information anymore, but connecting to Key Vault. And to do that, let me move to advanced. What it's going to do here is having this pointer to Key Vault. So this would be my original blob storage connection string before, where now we turn it into a Key Vault string, and obviously your function app needs to have the correct packages to recognize Key Vault, like a NuGet package, or if it's a Python, it would be slightly different. That's the idea. But most important, my function Azure resource is turned into a system assigned managed identity, and next we're going to provide correct permissions to do that. Another example is for where we run virtual machines. So I have a virtual machine. It's a web application running in Central US. And if you watched any of my other sessions here at Lunch Learn, you're going to see that I'm running a little e-commerce platform behind it. So let me show you that little application just to get some idea about what I'm doing. My application runs .NET on top of the web app, where it's pulling up some product images from Azure Storage, and the product details and the ordering system and the shipment and anything else that somehow builds up my e-commerce platform is coming from SQL Azure. So I could add some products into my cart. I could view my cart, and from here processing, logging on, creating an account, and that's all. Web app in a virtual machine. I have the same example with web apps, by the way. A virtual machine, SQL, Azure backend, and storage account. So a lot of secrets are moving around to make my application work. So instead of managing permissions like I did before with, what I did before with my service principal is now moved into managed identity. So let's go back to our web virtual machine, where now my virtual machine needs interaction with other parts of the platform. I select my web VM, and from there I did the same as what I showed you with the functions, identifying the identity topic, where now I could move this into user assigned. Why? Because with a user assigned, I'm going to create one single managed identity, and I'm going to link it to a web VM, a function, my storage account, or any other resource. Or imagine that instead of having one single web VM, I'm running 3 of them. Why? Because I like some better high availability, right? Or maybe I'm using web VMs across multiple regions, where now it means that I'm going to create a web VM. I'm going to use system assigned, like, hey, reach out to a function, reach out to Key Vault, reach out to storage accounts. And to somehow manage that in a more centralized way, I'm going to create one single user-assigned managed identity and linking it to multiple objects. That's where the user-assigned comes in. So I could go back to my other web VM and looking for a user-assigned one, where it's immediately going to show me like, oh, we already have something for web VM. Or the example I shared earlier, I created a generic one, and out of the user-assigned managed permissions, I defined that you can read Key Vault. So why not using that one? Because that's like the only purpose I have for this web VM. Connect to Key Vault, read out the SQL connection string, read out the storage account access keys. That's what I wanted to say. And that's it. So now I can go back to my next web VM and technically doing the same. Interesting enough, there is still that user assigned for the web VM itself, but nothing blocks me from adding multiple ones. So hopefully you start seeing the capabilities we have, where you can interact with multiple user assigns, integrating with role-based access, integrating with Key Vault permissions if you want, but it's also relying on RBAC in meantime and mixing those accounts together. Or the last example, if I switch to my virtual machine itself, and just gonna move it up a little bit so you can see what's happening as well. So remember I talked about PowerShell, talked about Terraform, and this is not working as it should be. Just a second. It should be good for now. There we go. It's a joy of working with different monitors with different resolution and every now and then having some weird activity. So imagine that this is my virtual machine, my management station, from where I'm going to run PowerShell scripts or CLI scripts or Terraform deployments. Where now instead of storing my service principal credentials inside my scripts, I don't even need to do that anymore. Why? Because what you could do is deploying an Azure VM, it's an Azure resource, turning it into a managed identity, system assigned or user assigned, and from there you can interact with the management plane of Azure. So what you can do, just an example here, is connecting to that 169.254, that's the internal IP address that Azure resources are using to connect to the management plane and reading out identity information. So my VM is authenticated or known in the platform if you want with that managed identity. And from there, I'm now injecting a basic web request just to show you some of the core capabilities. Like, hey, I want you to connect to management.azure.com, which by the way is only reachable from that 169.254. So it's an internal Azure management IP. And from there, I'm going to read out my subscription. And let me try and move this out a little bit. Let's see what happens. It's a little bit painful. Let's try and resize it just a little bit more. I don't need that much real estate for this window. There we go. Then I can scroll here. So I'm connecting to management.azure.com. Up here, reading out my subscription information and connecting to a resource group where I'm running my e-commerce environment. And then from there, you can basically do whatever you want because you're pre-authenticated. That's happening in the first step. From there, connecting to the backend plane and, for example, reading out what is the resource ID for that resource group. And that's what's coming up here. It's showing me that it's running in central US and the deployment was successful. From here, you could run Terraform deployments, PowerShell deployments, where again, you're not authenticating as the user, you're authenticating as the managed identity. Way cool. So with that, we're pretty much at the end of my session. So as a little recap, a summary, service principals, managed identities are super powerful and are the way to go to optimize application and Azure resources security. Server principals can be used for any third-party application, any connectors, like I showed you with DevOps tools, or Terraform deployments, or anything else, where again, you're not using your individual Peter admin account anymore. Managed identities on top of service principals are specifically used for Azure resources. Two different scenarios: system assigned one-on-one, one identity object, managed identity, linked to a single Azure resource, or you're going to turn into user assigned, creating a standalone managed identity and linking it to multiple Azure resources. And you could even link multiple managed identity user assigned objects to multiple Azure resources. Where I would like to thank you for being here. I hope you enjoyed it. I hope you learned from it. And maybe even more important, let's stay in touch, generate some buzz online on Twitter. Feel free to shout out and don't hesitate reaching out when you do have any questions. Enjoy the rest of the conference and enjoy the rest of your day. Talk to you soon.